Hello again in CCIA Security video number 2. We have some questions from that we got from the first video, and there are some information that we left over, so we will quickly go through them. Actually, the first question is talking about what, guys? As you remember, if you remember from the first video, that we already have talked about the VPN side to side, and we said that VPN side to side is having, or it has, two phases: phase number 1 and phase number 2. These are two phases, and as we said that the phase 1 is, this is phase 1 and this is phase 2. And as we said that the phase 1 is used to encrypt the Diffie-Hellman key or the session key. That's very nice. And we said also that the session key, that we are gonna use it in the second phase, that we will use in the second phase to encrypt the main data. And we said that the phase 1 is created to encrypt the main key. And as we said also that we need key encryption and hashing, these three main elements that I am using to encrypt the data. In the second phase as well, we need key encryption and hashing, these three things that we need to encrypt the data. One guy asked me from the first video, from the configuration, as if you remember, this is a configuration of phase 2. If you remember this line, guys: crypto IPsec transform set T-set ESP through this. And here, what we did here, we did the encryption. We did two things actually. We mentioned in this line two things. We mentioned the encryption and we mentioned the hashing. As you see here, the encryption and hashing. Someone asked me, where is the key? Where is the key? Okay. And if you remember, I told you the key is generated in what? The key is generated in the first phase. Yeah, as you remember, when we said cryptomobilizer camp and policy, and we said that policy, give it number, policy 10, and we said that the encryption is blah blah blah, hashing, and key was pre-shared key. And we used Cisco 123 as a password, as a pre-shared key, and we said that group 2 in the phase 1 configuration, we mentioned group 2. This group 2 is gonna generate what? Is gonna generate the Diffie-Hellman key, the session key, and this key is gonna be used in the phase 1. That's why I didn't mention it in the configuration. This is the answer of the question. Second question is, someone else asked me about if we can modify or change the lifetime of the session. And as you remember that the first session lifetime was 8600 seconds, and the second is 3600 seconds. This is a lifetime of the session key, as you remember. 1 hour. Someone asked me about if we can change or modify these two things, if we can modify these two, the lifetime time. Yeah, in phase 1, if you want to change or modify the lifetime of the first or the phase 1, you can write cryptomobilizer policy 5, okay, as normal, and you say lifetime, and you mention here what time you need actually. what is the duration you need. Here also, if you want to change the second one, if you want to change the phase 2 lifetime, yeah, you can do it. Crypto key IPsec security association lifetime second. This is a command actually if you want to use, and you mention here the time you want. Crypto IPsec security association lifetime second, and you mention that this is the second phase. This is the second phase actual lifetime. That was questions left over, or some of people they asked me from the first video. Let's go and continue. Okay. Today guys, we'll talk about GRE. Today guys, we'll talk about GRE. Okay. As we talked last video about the VPN site-to-site, and if you guys remember that we go in order to configure the VPN site-to-site or using IPsec, we were writing, if you remember, we were writing what? We were writing the ACL, the access list. And what this access list is used to define or to choose the interesting traffic that I'm gonna encrypt. Let me make it more clear. As we said that last time, there are two locations, two sites, and these two sites connected together through the internet. Here is the internet, this router, and we already made one router. He is is acting as an internet router, and we said that there are two networks here at two locations or two offices here, office 1 and office 2, and we created connectivity between both of them through the VPN site-to-site. Okay. If you remember, in the configuration itself, we mentioned the access list that define the traffic, that define the network is gonna be encrypted, and we used loopback 0. As you remember, we used a loopback 0 interface. It was acting as a private network here, located in location number 1. If you guys remember, 10.1.1.0 and here 10.2.2.0. These are two private networks. If these two actually want to talk to each other, we define them by the access list. That was the interesting traffic. Okay. In this things, actually, there is a disadvantage. I want you guys to agree with me that this has a disadvantage. What is the disadvantage actually? That in this way of configuring the VPN, as far as you using ASL and you're writing ASL for the interesting traffic, so that means that what actually? What if I have more than one networks? Maybe 100 networks here located in this office, or they are sitting here in this office. In that case, I need ASL for each of these, for each of this network. It means that I will write a lot of ASL, a lot of access list, in order to define it in what? In order to define it in the VPN, IPsec profile. Yeah, because you remember that the last the last step when we were configuring, we were using something called crypto map, and we say it, for example, imap, if you remember it, and under it we are writing what? We are writing the access lists. Address, we say address, and we mention the number of the access list. So if we have more than if we have more than network in each location, that means that I'm gonna write a lot of access list, and this is actually something which it is really a headache for the from the administration perspective. To overcome this problem, we came by a technology called GRE. What is GRE actually, and what is doing? Let's see the configuration. From the configuration, we'll understand actually what GRE doing. To configure the GRE, we are creating here, for example, if I have these two locations connected together like that. Okay. In order to configure the GRE tunneling here between these two sites, we mentioned that interface tunnel 1, for example, and give it IP address, and define the source real IP, outgoing real IP, and destination real IP under the tunnel. And by the way, we are created the GRE tunnel. Okay, what is the benefit? What is the benefit actually behind this? The benefit behind that is the benefit behind that is very simple. The benefit behind that is we can enable routing. We can enable routing here. So as we said that in IPsec, that depends on ACL, that's called policy-based VPN. Policy-based VPN. And in this case, in policy-based VPN, we are writing line by line, which is not practical. So that's why we came with this technology, which is GRE. And GRE, the advantage of the GRE, of using GRE, we can enable routing on both sides, as we will see here in this lab. According to my lab here, I have, you can say that these different locations or different sites, we can say that this is, for example, this is for example Dubai, and here, for example, India, and here Egypt. These three sites, or these three locations, we can tunnel between them. But first of all, we will talk about the GRE, which is one location to one location, single location to single location at the beginning, because later we will talk about something called multiple GRE, which is going to be site to multi-site. It will be one site to multiple sites. And later also we will talk about something called DMVPN. So let's go to the configuration, guys. But before the configuration, I'll explain exactly what is a lab and what is consisting what are the components of this lab actually. First of all, this is router 1 and this is router 3 is acting as an internet router, router 2 and router 4. Here, these are the public IPs as you see here, 192.110 between these two, and the public IPs here, 192.1.20 between these two, and 192.140 between these two. We will start to configure the GRE right now and see how it is working. We'll go to what? We'll go to router 1. Conf T. We are in conf T. So we'll create an interface, called it tunnel 1, and we'll give it IP. So the IP address I'm going to use here is, we'll give it a private IP, okay? 192.168, I'll give it 1.1 to the first location, or for Dubai 255. I'm going to create it, guys, between these two locations, between Dubai and Egypt, between Dubai and Egypt. Okay, so this is IP, and we'll say tunnel source. What is a tunnel source here? It's the outgoing real IP interface. So 192.1.10, 192.1.10.1, and the tunnel destination. Tunnel destination, guys, in Egypt is this real IP 192.1.20.2, like that. What about the other side? The other side is router what? What is the number? Yeah, this is router 2. We'll go to the router 2 and say conf T interface tunnel what? Interface tunnel 1, and I'm gonna give it IP address 192.168.1.2 255.255.5.0, and we'll say that it is tunnel. We'll give it a tunnel source. Tunnel source is what? Tunnel source is 192.1.20, guys. Dot what here? Dot 2. And tunnel destination. Tunnel destination is what? Tunnel destination is 192.1.10. Dot what? 10.1. By the way, guys, I want to show you the configuration, exactly the basic configuration. I have this all locations pinging to each other, and that they have reachability between each other. Actually, I created a static route here on router 3, because router 3 is here is the internet router. I simulated as an internet router, and I created a static routes here and default routes on each router. So I have a reachability between all of these sites. So now the tunnel created between Dubai and Egypt. Let's see it. And show IP. This is a tunnel 1 actually, internet address. This is IP of the tunnel. Now, the advantage guy here, we can enable the routing. So, what we can say here, what we can do here, we can configure EIGRP. So, we'll say router EIGRP, for example, 1, no auto summary, network 192.168.1.0 and network 10.1.1.0, like that on the router 1 and router 2 as well. We can say router GRP1 and no auto summary, network 192.168.1.0 and ten dot one sorry, on the 2.2.2.0, like that. And or we can say what actually? We can say conf t router EIGRP1 and network 10.0.0.0, like that. Fine. What is the advantage here? If you end and say show IP route EIGRP, you will notice here that we got 1 here. If you want to ping it 10.1.1.1, you can ping the other side. So I am in Egypt and I can ping this site through the tunnel itself. If you want to be sure, if you set trace route 10.1.1.1 and enter, what is the next hop here? The next hop is 192.168.1.1, which is the IP of the tunnel interface. The IP of the tunnel interface here on router 1, which is located in Dubai. That's very nice. So guys, here, what else? Here is the advantage of this thing actually. If you have more than network, let's say, for example, let's go to router 1, which is located in Dubai, and let's ping 10.2.2.2. This is in Egypt. Yeah, and I succeeded to ping it. If I said show IP route EIGRP, I'm gonna see to this. So guys, what can I already got advantage behind it, or from out of this thing? We can add here, for example, conf t interface loopback 1, and we can add IP address 10 dot, for example, 22.22.22, like that. Is it possible to ping it, the new LAN that I added here in Egypt? Could I ping it? Shall I ping it from Dubai? Let's try. Ping 10.22.22.22. Yeah, I able to ping it. So GRE enabled me, give me the capability of enabling the routing, the IP routing, dynamic routing. So guys, here let's see how the packet actually looks like. Here in GRE, we created a GRE between these two sites, Dubai and in Egypt, right? The packets look like what? When I created it, it will be like that. The GRE and the outer header. The outer header is 192.110.1, 192, which is real IPs actually, source and destination, and the EIGRP and what? And the IP of the tunnel interface. And what? Because I enable the EIGRP on what? On the tunnel interface itself. So this is the source, and the destination is what? Is multicast IP address of the EIGRP that we are sending hellos packet here to this IP address, to this multicast IP address, and the data itself, and the data here. What is the size of this packet? What is the size? The size here is what? Is 88 byte. Fine, fine. GRE. What is the disadvantage of GRE actually? The one I created right now between these two locations, or between these two sites. The disadvantage is the old data that get transferred from this location, from Dubai, goes to Egypt. It goes through the internet, and it goes in a clear text. It goes in a clear text actually. So to overcome this problem, we will enable the IPsec. We will enable the IPsec on the tunnel interface. How could we do, guys? Can you help me in this? Yeah, if you remember, guys, the last time we go through steps, and these steps actually to create VPN side to side in a secure way, and we created the encryption. We created the phase 1 and phase 2, and after that crypto map, and that after we created the crypto map, and we gathered, or we collected the all parts together in crypto map, we applied it into the interface. We will do the same thing today. What we're gonna do, we will create that first phase. We will configure the first phase. Let's do it on router 1. We'll say what? Conf T. If you guys remember, crypto ISACAM policy, and we give it a number, and as you remember, the number here is that we told that it's locally significant, and we are using it if just in case if we have more one session, we can give more than one number actually. And crypto map will say authentication pre-shared key, which is, we'll define it later, authentication, and encryption. What encryption I'm going to use? I'm going to use 3DS. Authentication, encryption, hashing. What hash I'm going to use? I'm going to use MD5. And group 2, which is Diffie-Hellman key. This is a phase 1, guys. As you remember from, this is the first step that we have done in order to configure the IPsec VPN. Nice. Okay, and we will say that crypto ISACAM key Cisco 123 and address. What is the address I'm gonna put here? The address, the IP address of the other side. Okay, I'm configuring Dubai. Okay, I'm gonna mention the IP address of what? I'm gonna mention the real IP address of the other end, which is Egypt here, 192.1. The bearing, guys, as you remember, 192.120.2, like that. This is a pre-shared key. This is a key actually I'm using in the phase 1. in order to encrypt the session key. Do you guys remember the second step? Step number 2 is phase 2. Phase crypto IPsec. Crypto IPsec what? Transform set. What else? Give it a name. Transform set and give it a name. T set, for example. And after that, what? The encryption and the hashing. We will use ESP .3DS and ESP MD5. This is what I'm going to use actually in the phase 2. So we finished phase 1 and finished phase 2. Do you guys remember that after that what we were doing? We were specify or define the access list. In here there is no access list actually. What we are going to do is, and there is no crypto map as well, we will use actually a profile, IPsec profile, and that profile will enable it on the tunnel interface. And by the way, we are encrypted the data. We'll say crypto IPsec profile. We will give it a name ABC, like that. Set, transform set. What is actually the phase 2 name I give? T set. T set. Now I'm going to apply it to the tunnel interface. I will say exit. I'll go to the interface tunnel 1, and I will say crypto IPsec profile. Sorry guys, it will be like that. Tunnel protection IPsec profile, and I'm gonna give the name of the profile T set. I called it ABC, right? ABC. Tunnel protection IPsec profile ABC. Enter. Yeah, now ISACamp is, yeah, it's on. Now I encrypted the data already. So by the way, we configure it on Dubai. We will configure it on Egypt as well. So guys, let's do it. Show running config. What? Section crypto. Here is telling me the other side is still actually here. As you see, the tunnel is failed down actually. The tunnel is failed. The connectivity fell down actually because of we created on one side and we didn't yet configure it on the other side. So once we configure the other side, actually, we'll take a copy, put it on the other side. We'll go to router number in Egypt, router number 2. Okay. But guys, write it here because I have to change it here. I have to make it 10.1. and I put it here. After that, what's gonna do? The second phase, guys. The second phase here. After we configure the second phase, what we'll do, we'll make a profile, IPsec profile, and we'll apply it interface tunnel 1. We'll apply it under tunnel 1, interface tunnel 1. Show running config. Interface tunnel 1. It's here. Tunnel protection and IPsec profile and the name of the profile itself. Now it is on. Yes, it is on. Hey, now what is it's telling right now? Now it became, the tunnel interface became up because both sides right now they are configured in the same way. So let's ping, for example, guys. Let's ping 10. I'm pinging right now from Egypt, which is this location. I'm gonna ping the LAN here in that located in Dubai, which is 10.1.1.1. Yeah, it's pinging. Show crypto ISACAM SA security associated. Is it good, idle? It's good, guys, as you remember. Yeah, we can see also IPsec SA. Show crypto IPsec SA. We will find that here. This is a source, and the packet, the number of packets that get encrypted, guys, here. Packet encrypted here. This is really amazing. Now, as you see here, the packet that created by created by GRE, okay, is 88 byte. What is after we added IPsec outer header? Actually, we put outer header. Yes, we put outer header. ESP. This is outer header, guys. Because when we configure phase 1, the peering itself was between what? The peering was between the public IPs. If you remember, guys, ISACAM security key or the pre-shared key that we configured the peering actually between these two. So this is the source and this is the destination. This is the outer header. So, but as you see here, there is duplication or no? There is duplication between this GRE source and destination, between GRE source and destination, and between ESP source and destination. Okay, in this case, this packet will be 140 bytes. 140 byte. It increased. The last time it was 88. Now it became 140 byte. 140 byte. Okay, guys. Okay. In order to limit, in order to reduce it, what we could do actually to reduce the length of the packet, what we could do actually, we can get rid of what? Actually, ESP. What is ESP? This is a protocol. As you remember, this is a protocol that, as we mentioned, phase 1 and phase 2, the ESP is used here to encrypt the main data, actually. So we can get rid of what? We can get rid of this duplication. How we can do it? If you go to the configuration, and say conf t interface tunnel 1, and you said it first, I want to show you exit, show exit one more time, show IP interface tunnel 1. What we gonna notice here? Oh, let's say show tunnel 1. Here, guys, internet address. Here is a broadcast. Here is the address determined. This is actually sorry. Show guy is actually the tunnel is in a tunnel mode right now, but we can change it into conf t interface tunnel 1, and we can say mode sorry guys, exit the crypto itself. The IPsec is in tunnel mode. Show IPsec, show IPsec or show crypto IPsec mode or SA. You will notice that all of this is what actually is tunnel mode. It's in a tunnel mode. Okay, we can change it. Yes, we can change it. Show running section crypto IPsec. Section crypto try it all. Here, guys, crypto IPsec transform set is set. If I take like this, put it like this, and we change the mode into what? From tunnel mode to transport mode. Transport mode. What gonna happen here? What's gonna happen here is, instead of this duplication, we will remove this duplication here. So it will be like that. And here there is no more, because the outer header is already similar between the IPsec and the GRE. The IPsec itself, the ESP, is initiating the traffic, is moving the traffic, so there is no need for GRE outer header anymore. By the way, we are reducing the packet to 124 byte. We are slimming it. We are making it thinner. Okay? Fine. Could we have it more slim? Yeah. We can do it. Yes. How? Yeah. But before I forget, guy, let's go to the other side as well and make the mode to transport. We'll take a copy. We'll go to router 1. Conf T. And what we'll do here, we'll make the mode from tunnel to transport. We can reduce here also, we can reduce what? We can reduce that size of the packet. Yes, we can do it. What we can do here, in the third step, we can do like that. We can get rid of GRE packet at all. The encapsulation of GRE, we're gonna remove it. How we could do it actually? In the configuration itself, you will go to conf T interface tunnel 1 mode or GRE. You can say tunnel mode what? What is the mode we're gonna use here? We can use it as IPsec mode. IPsec mode. Incomplete command. IPv4 because it is IPv4. In this way, this is called local IPsec local interface. IPsec local interface. It's called native IPsec tunnel interface. Native IPsec tunnel interface. We'll go to the other side. Where is the other side? Router 2. Exit. Interface. Tunnel 1. Tunnel mode. IPsec. Yes, IPsec. IPv4. IPv4. This is native tunnel IPsec. Native tunnel interface IPsec. We reduce the packet, yes, we reduce the packet, yes. The packet now is without TIGRP at all. It's IPsec only. What is the length of the packet right now? It's 116 byte. 116 byte. Okay, guys? In this solution, GRE solution actually, we created a tunnel between these two locations, Dubai and Egypt. This is actually is applicable, or it is a good solution if we have a small number of sites. But what if we increase the number of sites right here? If we put site 2, site 3, site 4, GRE is, in this case, is going to be applicable. It will not be suitable. So we will talk later about something called MGRE, multiple GRE, in the next video, and a DMV VPN as well. See you in the next video. Thanks for attending.